Okay, so now we know about how to work out the expectation and variance. Let's look at an exam style question. So I've got two samples of 30 driving test results taken, and I know the probability of passing is 0.6. So I've got to find what it's chosen to call the expected mean. Well, the expectation and the mean are the same thing, and the expected mean, they're just saying it twice. So this is the expectation. The standard deviation, well, we're going to be using the variance formula and then converting to a standard deviation. So the first thing I've got to do is check its binomial. Okay, so I actually need to know that I'm counting the number of passes, I think. As long as I'm counting the number of passes, then I'm counting the number of successes in n independent trials. N is going to be 30. I have to assume that the results are independent, but if they are, then X has got a binomial distribution with 30 trials and a success probability of 0.6. So that's my value of N, that's my value of P. So in part A, I want the mean and the standard deviation. So the formulas I know are the expectation formula, which is NP. This is telling me the mean. So 30 times 0.6, which is 18, and that's the mean, mu. Okay, and the other formula I've got is the variance one. So var of x is NP 1 minus p, which is n, which is 30, times p, which is 0.6, times 1 minus p, which is 0.4, which is 7.2. But that's the variance sigma squared, but it asked me for the standard deviation. So the standard deviation is going to be the square root of 7.2, for which I need my calculator. Square root of 7.2 is 2.683. Okay, that was part A. Part B. In the first sample, the mean is calculated as that, and the standard deviation is that. And in the second one, I've got a different mean and a different standard deviation. Okay, so I've assumed that it really was binomial. So I mentioned at the beginning some of the things we had to assume, and one of them was independence. Now, if the sampling isn't random, then independence may not be true. So where it says which of the two samples used a random sampling technique, okay, we need that to be true for it to be binomial. So maybe one of them isn't binomial. Now, if you look at the given values for the mean and standard deviation of the first one, so I've got a sample mean of 18. Now, I don't expect the sample always to have exactly the same mean as the probability distribution, okay, and 19 and 18 are not too far apart, so that's kind of in line, and the standard deviation of 2.5 is in line with the theoretical value of 2.683. So I'm going to say that 19 and 2.5 are similar to the 18 and 2.683. So sample 1 could be random. Now for the other one, the sample mean was 17.4. Once again, not too bad for 18. However, the sample standard deviation of 5.3, so it's 5.3 I need to focus on, is a long way from the theoretical value of 2.683. So this is all on the assumption that the sampling was random, because the events have to be independent, and the actuality, the actual value, isn't in line with that. So I'm going to say that sample 2 probably wasn't random. I mean, possibly it was, and the results took place by chance, but from the data I've got, that seems like the most reasonable conclusions. And the question very clearly hints that one was a random sample, the other one wasn't. So I would very much bet on sample 1 being the random one and sample 2 not being.